Okay, so on the back of that close note sheet that I gave you yesterday is notes 4.4b called the factor theorem. And like as you think about it, I'm going to start giving you more theorems or different things that we need to know each day in class. So chapter 4 is a long chapter. It would be a good idea for you to be going back to the early parts of your notes and reviewing things. Okay, so you should be reviewing on a regular basis. Don't wait to cram it all in right before the chapter 4 test. That's going to be a lot to learn in a little bit of time. So we're going to start with the factor theorem right there in that top bubble. And the factor theorem says, let's see if I can zoom in at all. A polynomial has a factor of, and you're going to put in there x minus k. So could you imagine x minus k in a group of parentheses? It looks like a basic linear factor. It's a linear factor if you want to mark that. It has a factor of x minus k if and only if f of k equals 0. So we've talked about f of k before. What is f of k? It represents y, right? So it's the y value when x equals k, right? So it's the y value when x equals k. There was one other theorem we talked about. Kristen is saying the remainder theorem, and f of k was in the remainder theorem. In the remainder theorem, f of k is the y value when x equals k. It's also the remainder, right? So like you can do synthetic division, and the number that's at the very end, that's in the remainder spot, that's the value of the polynomial, right? So f of k right here is also the remainder. So make a little note to yourself. When you see that notation, f of k, it's talking about the remainder. And so I'm going to put that into my own words on the next line. It just says x minus k is a factor if the remainder equals 0. Okay, so it's a little bit less mathy because it doesn't use the f of k. But f of k just represented the remainder back in the remainder theorem. Okay, so it's kind of reusing that notation. Okay, now that should make sense with what you know about factors in general. So going back to Kinsey's question on the homework assignment, I was saying, okay, give me the factors of 20. And you guys said 1 and 20, 2 and 10, 4 and 5. Why didn't you say 6 and 20 over 6? Whatever that is. Why weren't those a set of factors?
Doesn't logically seem correct if you're going to use all whole numbers and put 6 and 20 over 6.
Okay, you like, when you list factors, you like to list things that are whole numbers or integers. Okay. What's true when like all of those things come out to be whole numbers or nice numbers in division? What's it saying? Like when you do the division problem with 20 and 2, what's true at the end of division? The remainder is 0. There is no remainder, right? So like this is just saying the thing that we would agree with from elementary school when we learned what factors were. The factors are only the nice ones or the ones that go in nicely. So we got to get that 0 remainder. Okay. All right, let's do the first box on the left. We're going to determine whether or not x minus 2 is a factor of f of x equals 4x cubed minus 21x squared plus 9x plus 34. And we know from the factor theorem that x minus k is a factor when the remainder equals 0. So I want to find the remainder, which basically means I want to do polynomial division. Now, would you probably choose long division or synthetic division? Synthetic. Sierra had really big eyes there. Please, synthetic, right? Yeah. So let's set up synthetic. Now, what's the highest exponent in this f of x? X cubed, so I gotta have an x cubed, an x squared, an x, and a number. And I'm gonna drop in the coefficients 4, negative 21, 9, and 34. You guys got your quizzes back yesterday, and on some of those synthetics there was a missing term, and some people didn't put their zeros there for the missing term. So if you're kind of forgetting your missing terms every now and then you need to be writing all these X's on the top of your synthetic so you hold yourself accountable. If I'm checking x minus 2, what am I going to put on the outside of my synthetic box? A 2, a positive 2. So for this one, it's just like when we did synthetic division, x minus 2 equals 0, x equals 2, so we got to change the sign when we put it outside. When the book tells us evaluate the polynomial when x equals 3, if it already looks like x equals, you just put that number out there. Okay, so what are we looking for at the end of division? A 0. Why don't you work through and see if it works if you haven't already. So remember, add down and multiply. Work it out. See what happens. I put my answer up on the board. I got a 0 remainder, so I'm feeling pretty happy. I put a little happy face in there. Is x minus 2 a factor of the polynomial? Yeah. What if it's not a 0 at the end? Then what would you answer? No. Okay, so there's going to be some questions on your homework assignment that are just like determine whether or not it's a factor, do synthetic. If you get a 0, say yes. If you don't get a 0, say no. Maybe not. But make sure you set up your synthetic correctly. Okay, now we're going to go over to the next box, and this has a different set of directions. So you'll have to be careful here and make sure that you can read the directions and like understand what it's asking you so that you can like set it up and do some stuff. So it starts by saying, show that x minus 2 is a factor. So how would you show that it's a factor?
You do the same thing.
Do synthetic and show that it comes out to 0. Now, if I use the direction show that it's a factor, you can bet it's going to be a factor. It's not the same as determine whether or not it's a factor. Okay. So we know we should get a 0, right? Okay, let's set this up. What's the highest exponent in that polynomial? X to the 4th. We're going to have x cubed. We're going to have x squared. X and a number. Drop in my coefficients. Ooh, I gotta be really careful here. I'm missing x squared, so I gotta have a 0 there. And that will affect the outcome of my final answer if I don't have a 0 there. What number will I put outside the synthetic box? 2 again. X minus 2 is the factor I'm checking, so x equals 2. And then do your synthetic. So I know it should come out to a 0 if I'm reading this set of directions and it says show that this is a factor and I don't get a 0. I'm going to check my setup. I'm going to check my add, down, and multiply. I must have made a mistake. I'm getting a lot of zeros here. Oh yes, and I end with a 0. So I'm feeling pretty good. That's supposed to be a smiley face. It looks a little stern. But he is excited. He's just concerned because he knows there's more in the problem.
I'm scared too. Me too, little 0.
Okay, so we have showed that it's a factor, right? Now the next part says then factor completely. Okay, so now we want to write out the polynomial with its factors. So if we show that x minus 2 is a factor, then that's one of the factors, right? We got to write that one down. Okay, so one factor is the one we checked, x minus 2. The other factor, this is good, kind of goes back to like the volume of our box problem. is what's left over as your quotient. Okay, because it's like if you want to know factors of 15 and you know one of them is 5, to find the other factor, divide 15 by 5 and you get 3, remainder 0, right? Okay. So our quotient here is going to be our other factor. Now you have to be really careful here. If this was x to the 4th, what's this one? X cubed. And I don't really have to worry about all these zeros. If this was x, this is now the number, the constant, the one without the x, right? So this is x cubed, this is x squared, this is x, this is the number, and this is the remainder. So when I write out the other factor, it's going to be 1x cubed, and then minus 1. Doesn't have an x on it. Okay, so now I got two factors. What do you notice about my factor there, x cubed minus 1? That's the difference of perfect cubes from yesterday. Okay, so you're looking at the binomial, and it could be factored again. So if it says factor completely, I got to keep going. Okay. So I know I'm going to have an x minus 2. And then I'm going to have my two groups of parentheses. One's for a binomial in the sum or difference of cubes. One's for a trinomial. Remember, you are responsible for basically memorizing this factoring rule. Okay, so to use the factoring rule for sum and difference of cubes, you need a and b, which a and b are your cube roots. Okay, so a cubed is x cubed. What's the cube root of x cubed?
X.
X. So a is equal to x. Your b cubed is 1. What's the cube root of 1? 1. And then we follow the rule for the difference of perfect cubes, and we're going to use SOAP. So what's in the first binomial? X minus 1. A minus b. Same sign as what's in the problem. What's the first term in the trinomial? X squared. What's the sign going to be here? Plus the opposite sign. What's the next term? 1x. You're multiplying x times 1, which is just x. What's the next sign? Plus, always positive. There's my SOAP. Same opposite, always positive. And what's the last term? 1. B squared. 1 squared. Okay. And remember our conversation yesterday? You never ever have to worry about factoring out this trinomial. It won't work. It's imaginary. So that's nice if you know that about sum or difference of cubes. Okay, not too bad, right? Just keep factoring. Factoring is life now. Okay, let's go to the very bottom. And just like the quadratics in chapter 3, you can solve polynomials by factoring. So there's basically 3 steps. They're quick and easy. I'm going to jot them down. Step 1, factor. Step 2, set factors equal to 0. Step 3, solve for x. When you solve by factoring, those are your basic 3 steps. Whether it's quadratics, polynomials, doesn't matter. What do the real solutions look like on your graph?
They're there.
They turn into x-intercepts, right? Okay, so this is going to be really important later in the chapter. Now that we're going to be able to solve polynomials, if we can find those x-intercepts on the graph, then we don't have to do that whole table of values that we did back in section 1. Okay, remember, we're going to do x and y and evaluate the polynomial in all these different places. We're just going to find where it crosses the x-axis, where it crosses the y-axis, and graph it out in behaviors. Okay, so let's try this example over here on the side. 48x to the 5th minus 3x equals 0. Now notice this problem is different than the things you did on your homework yesterday because it now looks like an equation. It has 2 sides. If you look back in the book today and you see the problems that you did yesterday, they're just expressions. things that you factored but you didn't have to solve for x because they weren't equal to anything. Now we know it has to be equal to 0. Okay, so what do you notice about those two terms?
Well, you can take the GCF out of it.
Take out our GCF. Work smarter, not harder. So what do they have in common?
3x.
3 and x. What's left over? 48x to the 5th divided by 3x.
16x squared.
16x
To the
4th. What about when you do 3x divided by 3x? 1. Okay, so some people might have some issues on their homework if you ever made that last term disappear because the GCF came out. It doesn't disappear, there's got to be a placeholder of 1 so that if you redistribute, it goes back to the original problem. Okay, what do you notice about your factor now? Perfect square. 16 is perfect square. X to the 4th is perfect square. 1 is perfect square. So we're going to factor by difference perfect squares. 4x, what'd you say?
Squared.
4x squared is the square root of 16x to the 4th. So we use our square roots instead of our cube roots. What's the square root of that second term? 1. Also 1.
Yeah, plus minus.
And then 1 is plus and 1 is minus. That one's so easy. Okay. And what do you notice now about your factors? You can do it again.
Huh, that must be easy.
Okay. So 4x squared plus 1 can't be factored because it's the sum of perfect squares and there is no factor for that. But 4x squared minus 1, those are all perfect squares again, right? So just like keep going until I'm all done with all my factors. Okay, so always double check. What is the square root of 4x squared?
2x squared.
2x. And then what's the square root of 1? 1 again, and we'll have plus 1 and minus 1, and that equals 0. This sum of squares, we're going to solve it here in a minute by setting our factors equal to 0 and solving for x, but this is going to produce imaginary solutions, so you won't be able to factor that. Because I know that. A sum of squares always produces imaginary solutions. Like, there's, this one's not so nice because it has the 4 right there, but let me just give you x squared plus 1. Do you agree that this is the same as x squared plus 0x plus 1? Okay. And now I can use your shortcut because my leading coefficient is a 1. What are factors of 1 that add to make 0? That's not factor of 1. There aren't any, so you can't factor it. That's true all the time with sum of squares. Difference of squares, yes. Because it will be a minus 1, so what are factors of negative 1 that add to make 0, 1, and negative 1? So they're going to be opposites. Okay, so we have factored. We've done step 1. Now we got to do step 2. Set all our factors equal to 0. We have 4 factors. Set them equal to 0. 3x equals 0. What's x? 0. 4x squared plus 1 equals 0. Now, I'm going to do a couple steps right here in a row. And I'm not going to write them down. If you need to write out individual steps, you can. To solve for x, I'm going to subtract 1. And then I'm going to divide by 4. So that would leave me with x squared equals negative 1 over 4. Okay, if you need to write down the individual steps, please do. I subtracted 1 from both sides, and then I divided by 4. How would I solve for x? Square root. What are things that are important for me to remember when I square root to solve?
I.
But I'm in algebra 2, so I can square root a negative. It gives me I, an imaginary value. And what else do I have to remember about square rooting to solve? I'll take, like, if I'm doing the square root of a fraction, the square root of 1/4 is the square root of 1 over the square root of 4, which is 1/2. If that didn't come out nicely, I might have to rationalize my denominator, right? But I don't. So it's going to be 1/2 I. What else do I have to remember? Plus or minus. 2 answers. Okay, so this is plus or minus 1/2 I. That's 2 answers, right? And then I have 2 more factors to go. 2x plus 1 and 2x minus 1. I'm going to set those equal to 0. Yep. Subtract 1 divided by 2 is negative 1/2. Add 1 divided by 2, that's 1/2.
Yo, wait, is it 1/2 for both? Like positive 1/2 for both of them?
Nope, 1 is negative and 1 is positive.
See, that's like the plus or minus that you have in there, but with the I.
Yeah, that is the plus or minus because, like, could I have actually solved for all of my x's back before I did the second difference of perfect squares? Sure, I could do 4x squared minus 1, add 1, divide by 4, that's 1/4, square root it, and I'll get plus or minus 1/2. Since we're in the factoring section, I'm going to, like, do all the factoring, right? Okay, but you would have gotten plus or minus 1/2 either way. How many solutions are there right there? 5. You got 0, 1/2, negative 1/2, and then you have plus or minus 1/2 I. So that's 2 solutions. What's the degree of the polynomial we just factored? 5. How many total solutions should a 5th degree polynomial have? 5. So I found all 5 of them.
But like, if they were I and they're imaginary, that means they won't go on the graph, though, right?
Right. You'll only see 3 x-intercepts on the graph. The other 2 zeros are imaginary. But you'll have to pay attention, and this is going to happen later on in the chapter. Like when you read the directions, it might say find all the zeros. So then you have to have as many as the degree. Or it might say find the real zeros. So then you only have to find the ones that are real. So you would have 3 here.
What do imaginary zeros look like on a graph?
They don't really look like anything. But sometimes with polynomials, you can see like a bend in your graph. It's not a turn, but it sort of like looks a little wonky. Sometimes that's a signal that there are some imaginary zeros. But you don't always see them. Like a parabola was always a perfect parabola. It just sat above the x-axis. So you didn't really see it there. All right, any other questions you want to ask me? All right, you got 15 minutes. Every pod should be working on the homework assignment. You can share a book with the people in your pod. You can take a picture. You can go online. Whatever works.
How I feel from